Okay, hello, OnRamps. For those of you who are absent or out or just need to refresh the RStudio introduction, we're going to go through the homework together. This is where I'm going to go first if you have not logged into RStudio. So if you'll click this, RStudio is our statistical software that we'll be using this year. And it's a place that we can do run statistical tests. It's also going to be our calculator for this year. So it should take you to this Posit Cloud registration. Please click the blue link here. This will register you for the thing it might ask you to sign in. And then it's going to tell you to join. Now I've already joined, but if you'll join that. And so here, this hamburger menu here, we want to make sure that we're always in 2526 Holloway. This is where all of our content is going to be. And it should say elementary statistical methods. If you will, might say start with a little blue button there, or resume if you've been in it before, but it should take you to this screen. Now I want to highlight this key features part and kind of talk you through what it's going to look like in your RStudio screen. See if I can make this a little bit bigger, but I guess not. So when you get to your screen, this top left hand, and right now you don't have a top left hand, this is your screen, your script editor. So if you'll please click the plus sign here and our script, we're going to open up a new script window. You're going to be doing all of your writing or typing in this window. Don't type anywhere else, only type in this window. So that's our script editor. Oh. Where did that page go? There it is. So the script editor is where you'll write your script, and you can save your script using this little blue floppy disk here. And you want to press the run button to run a script. So if I put in like 7 plus 5 as just a calculator, I want to make sure that I press the run button so it can run the current line of script that I'm on. So once I press run, if you notice, nothing shows up here, but my output is down here in the console. So my 7 plus 5, we know it equals 12. And this is confirmation here. It's going to tell me the answer 12. So your output is going to be in this console down here. So the script editor is top left. The console is bottom left. And then let's look at this top right corner here. The top right corner is the environment. This is where all of your data sets are going to be. This button right here, the import data set, is the button that we're going to be using the majority of the time to import any data that OnRamps wants us to use. And we'll use that in just a moment. So this down here is our files, plots, packages. We won't use this today, but anytime that we write a script to draw a histogram or a box plot, and you run that, your visual is going to show up down in this right-hand corner. And if you've noticed, I've already been toggling some of these frames to make them larger or smaller. So if anything says your frame is or your window is too small, you can make it larger that way. All right, so let's go ahead and start by importing a data set from text base. You always want to choose the first one. We're going to choose OnRamps data and Karloff Hue. And so whenever we import a data set, we want to rename it something that we can use. We're going to be writing a lot of scripts with it. So we want to make sure that we type it in a way that makes that we can retype it a number of times without any difficulty. So I'm going to rename it Karloff, lowercase k. If you'll rename yours that way as well, that way your coding will look like mine. So make sure that your heading says yes, and then we're going to import. So if you notice, my data that I imported shows up here. I have a table, kind of looks like a spreadsheet with all of this information shows up here. So what is this table telling us? Well, Karloff is the name of our data set. There are 100 observations. That means that there's 100 people in this study. So you can see the numbers on the side. That's all 100 people. And there's 16 variables, and the variables are the headings here. So these are the variables of interest. You can see those up there. There's 16 titles. All right, so now I'm going to, now that I imported the data set, I'm going to go to my R homework and we're going to go through this together. So here's my R homework and we just did this together. We imported the data set, we selected Karloff U and we renamed it Karloff and we said yes for heading. Right now we're going to look at the spreadsheet view of the data to answer the following questions. So how many observations and how many variables? So if I look, OBS means observations and there's 100 of them. So I'm going to put 100 here. How many variables? We talked about that already. That's 16 variables. So I'm going to put that here. All right, then question 2 says how many records of female students are there in the data set? And how many male students? Well, instead of going through here and counting all of the females and males, I can use a table. So let's, I'm going to give you a note here. And whenever I want to write myself a note, I'm going to start with a hashtag and it turns it green. And I'm just going to say to make a table, this is how we do it. Here's our function. We're going to write table. We're going to open parentheses. We're going to type our data set and then do this $sign and then type the variable. So remember the variable is the heading. So let's try to make this table here. So we're going to type table. My data set is Karloff, right? I'm going to do the $sign and I want to know males and females. So which heading is going to have the males and the females? Well, it looks like the sex heading, because if you notice, these are all the data pieces in here. So then we do sex. So now I'm going to just say run and notice that it pops up down here. So there are 33 females and 67 males. So you can answer question 2 now with that table function. All right, so we're going to use the full-time variable to determine how many students in the data set are full-time students. So we're going to use the table function again. And we're going to use Karloff because that's the only data set that we have. And we're going to figure out how many full-time students there are. So I need to figure out what is the variable that contains full-time and not full-time. Well, there it is, full-time, and I can click on it. So make sure if you're typing this in that you're typing it exactly as you have written your title here. Capitalization matters, spelling matters. All right, so that brings up my table of no, not full-time, and yes, full-time there. All right, so that'll help you answer question 3. All right, so question 4, it says use the variable credit hours to create a subset containing only those students who are taking 12 or more hours. Look at the number of observations in this subset and refer to your answer in question 3. Okay, so what I want to do here is I want to create a subset. So here's my note to myself to make a subset. Now a subset is, I have my data set Karloff, and I want to pull out a certain number of students and make another table based on just that number of students. So here's how we do that. We're going to name the subset. We're going to do this little arrow guy. We're going to type the data set, square bracket, type the data set again, $sign, whatever we want the variable to be, equal, equal, and then we want the condition. Now, the biggest thing that people forget when they do a subset is to make a comma here. So don't forget to put the comma after you put the condition. All right, so let's make our subset. We want a subset of, where'd it go? There it is, okay. We want a subset containing full-time students. So we're gonna name it full-time. We're going to do our arrow, and our data set is Karloff, square bracket, Karloff again, $sign. Now, where would I find students that are full-time? Oh wait. Yeah, full-time. Oh, wait, what is it asking me? Oh, subset, credit hours. So we have to do credit hours, not full-time. That was the last one. So we're going to do credit hours. There it is right there. Make sure it's capital. And now we want it to say 12 or more hours. Well, that's not equal to 12 hours. That's greater than or equal to 12 hours. So I'm going to write a greater than sign and then an equal sign, not equal equal. And then it's 12, so I don't need the parentheses since it's a number. All right, so we're going to run this. And if you notice, we have a new subset of just full-time students. So all of these are, yes, they're all full-time, and they have credit hours of 12 or more. So it says, how many hours must a student take in order to be considered full-time? Well, that's 12. All right, here's the next one. Wendigospi is the condition which turns students into wendigos. How many students were diagnosed with Wendigospi? So we're going to use the variable diagnosis. So I want to create a table of how many were diagnosed with Wendigospi. So we're going to make a table. I'm going to pull it from Karloff, our original data set, and then it said diagnosis. So I'm looking for that. Here it is, variable. Run that. Okay, so it tells us that 59 students were diagnosed with lycanthropy and 41 students were diagnosed with Wendigospi. So here where it says how many students were diagnosed with Wendigospi, I can use that table to help me. All right, now it says create a subset. So we're going to create a subset again containing only students with Wendigospi. So here's our subset. Let's call it Wendigo. And we need a data set. So our data set was Karloff, square bracket, Karloff again, $sign. And where would I find the people that are diagnosed with Wendigospi? It's diagnosis. So this one is equal because I want my condition to be exactly equal to Wendigospi. So I want to look at this just in case, because I need to make sure that I spell it right. Wendigospi. Okay. All right, don't forget your comma after that, and we'll run it. And notice nothing shows up here because I've created a new subset, Wendigo, and there's 41 observations. So it says, how many records? Records are the same as observations, so that would be 41. Use your Wendigo subset to answer the following question. What was the common moon phase for students with Wendigospi when they visited the health clinic? So I want to know in a table, and now I'm going to use the subset Wendigo and the moon phase to figure out what it was. So it looks like full moon was 10, new moon was 19, and partial moon was 12. So that tells me what was the most common moon phase. Well, I'm looking for the highest number. That would be new. All right, next one, lycanthropy is the condition which turns students into werewolves. So we're going to create a subset containing only students diagnosed with lycanthropy. So here we go again. Creating a subset, we'll call it lycanthropy. Spelling matters. I'm pulling it from Karloff. Karloff again. $sign. I'm using diagnosis again because I want it to equal lycanthropy. All right, comma, and run that. So if you notice lycanthropy, there were 59 people that were diagnosed with lycanthropy. But it says, what was the most common moon phase for students with lycanthropy when they visited the health clinic? So let's do a table again for lycanthropy. Oh, can't spell it. $sign, and we want moon phase. Don't forget to run. So it tells us that it's a little bit different than the Wendigos. It says 36 for full moon, new moon is 11, partial moon is 12. So that means that the most common was the full moon there. right? So you'll select that one. All right, how many more male werewolves visited the health clinic than male wendigos? So I want to know the number of male and female, or really just male. So I'm going to use a table again for my wendigos. And I want to know the sex because I want to know how many males went to, so 26 males that were diagnosed with wendigo went to the clinic. Now let's find lycanthropy. And we're going to use sex again because I want to know how many males and females. So 41 males diagnosed with lycanthropy went to the clinic. So 41 as opposed to 26. The question is how many more werewolves than wendigos? So I need to find the difference, 41 minus 26. So it can do basic math for you. And so your answer there is 15. Now the last one is what percent of the wendigos who visited the health clinic are male? Well, what percent is what you want divided by the total. So what are we looking for? Are we looking for wendigos? Okay. So there's 41 wendigos and there were 26 males. So it's 26 divided by 41. We're going to multiply that by 100 to find out our percentage. So the percentage of male wendigos was 63%. And it asks us to do the same thing for the lycanthropy, the werewolves. So it was how many males for the werewolves? That was 41 out of 59. So 41 divided by 59 times 100, and it tells us 69%. All right, so that was kind of our introduction to RStudio. I encourage you to do these codes in your RStudio. That way you can get a little bit more comfortable with it, even though you weren't here. And we'll see you next time.